Not going to waste your time here. These are the important things you need to know for part 1 of this chapter. So, two variable equations are in the form of a1x plus b1y equals c1. Then you have a2x plus b2y equals c2. Now, if you have some cases for these equations. So if a1 over a2 is in fact not equal to b1 over b2, then we say that these lines are intersecting. This is the most common type of lines you'll get. It's where they're intersecting exactly one point. So, for example, that's the point of intersection. And this relation right here needs to be true. The other case we have is if a1 over a2 equals b1 over b2, which also equals c1 over c2. In this case, we say that these lines are coincident. In other words, one line lies on top of the other, or they're just the same line. So, for example, 2x plus 4y equals 5. And the other equation is also 2x plus 4y equals 5. Then these are the same line. We call them coincident. Okay. Parallel lines is if we have a1 over a2 equals b1 over b2, which is not equal to c1 over c2. We say these lines are parallel. It means they never intersect and they have no solutions. So this one has infinitely many solutions. Okay, this one has no solutions. And up top here, this one has one solution. You can determine this using the ratios I just discussed. Now the next thing we have to focus on is how do we solve a system of linear equations or a two variable two equations system by graphing. It's pretty simple. You just graph each line and then we just see where the lines intersect. For example, if I'll give an easy example, y equals x plus 5, and then I'll say 2y equals 4y plus, or 4x plus 8. So how do we solve this using graphing? Well, we need to get it into slope-intercept form in order to graph. You should have already learned this in the past. Okay, this one is y equals 2x plus 4. Okay, and up top, this one is still y equals x plus 5. And now we can graph it. So obviously you guys should be doing a better job at this because I'm obviously writing on this. Y equals x plus 5 means slope of 1, and the y-intercept is 5. Only way that's true is if it passes through this point and then just goes parallel to y equals x. Something like that. And 2x plus 4 has y-intercept of 4. And then the other way you can graph this, other than just by looking at the slope, y-intercept of 4 means x 0, 4. And then, so you need the slope to graph this, so we're going to go through this point, and then since it's a slope of 2, remember slope is the change in y over the change in x. So we're basically doing plus 2 plus 1, or minus 2 minus 1. So we change y by 2, 1, 2, and x by 1, 1. We get that, and then we can graph this. So something like that. Obviously, I'm not using a coordinate grid, but if you were using a grid, just figure out what this point is. Obviously, we have these points and stuff. Figure out what that point is, okay? And basically plug in those values. Looks like it's 1,6. Is it 1,6? It's about 1,6. If I put one more mark up there. Let's see, 1,6. Okay, so it is 1,6. So yeah, as you can see, I was pretty accurate with that. It's 1,6. Be sure to check your solutions. You should have an x and a y value for this system. So that's how you solve by graphing, and that's part 1 of this chapter.